Here we have the same example we discussed in the last lecture, and we have a function with three variables, and we wrote the min terms and max terms. There is a question: do we need to have the truth table, like, to find the min terms? For example, I say M4. Do I have to write this part of the truth table and write M4 and look to the variables and to see which variables should be applied to the gate which yields a 1? So M4, we know that is a B bar C bar. So if somebody asks us what is M6, can we say directly what is the variables for M6, or do we have to draw this to a table to say which variables are corresponding to this M6? So here is the answer. In fact, we don't need to write the truth table to find the minterms. There is something called minterm code and maxterm code, which helps us to write the minterms directly from the function, not from the truth table. Okay, so minterm code and maxterm code. So let's start discussing minterm code and maxterm code. First, we will talk about minterm code. Let's say we have, okay, there is a simple rule before writing an example. There is a simple rule: 1 for variable and 0 for complement. This is a simple rule. Just try to remember this simple rule for minterm code. If you know this rule, we can directly write the minterms from the function, not from the truth table. So here is example. Let's say we have this function: f of a, b, c is equal to a b bar c plus a b c bar plus a bar b bar c bar. Okay, we learned how to find the minterms from the truth table in the last lecture. What about the finding the minterms from the function? Here is the answer. We need to use minterm code. How we can use minterm code to find the function? Using this simple rule: 1 for variables and 0 for complements. So for any variable, we assign it with 1, complement 0, 1, 1, 1, 0, 0, 0, 0. Okay, now which binary number is 101? 101 is 5, so it is minterm number 5. 110 is 6, so it's minterm number 6. 000 is 0, so it's minterm number 0. So we can simply say the function is m5 plus m6 plus m0, or sigma of minterms 0, 5, 6. So we don't have to write the truth table for this function to find the minterms. We can directly write the minterm from the function. Now, maxterm code. Maxterm code is the opposite of minterm code. Okay, again, a simple rule. This time, 0 for variable and 1 for complement. It's opposite of minterm. Let's see. let's assume we have this function f of a, b, and c is a plus b plus c, a plus b plus c bar, a bar plus b plus c, a bar plus b plus c bar. We want to write the max terms from this function. So again, we apply those codings. So a, the variable is 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. 0, 0, 0 is 0, so it's max term 0. 0, 0, 1 is 1, so it's max term 1. 100 is 4, so it's max term 4. 101 is 5, so it's max term 5. So we can say the function is equal to m0, m1, m4, m5, or the product of max terms 0, 1, 4, and 5. Okay, so this one is the answer. Okay, so now let's design a circuit. Example. So example, design the simplest sum of product circuit that implement the function f of a, b, c is equal to sigma Minterms 2, 3, 4, and 6. The first thing, it says the simplest, so it doesn't have to be canonical. So we can simplify the function. So we have the max terms, and we need to find the function. In order to simplify, we need to find the function. How we can find the function from Maxterm? Do we need to do out the truth table? We can, but it's not the most efficient way. We can use Minterm coding to Minterm codes to write the function directly from these Minterms. So how? Here is the solution. F is equal to Minterm 2 plus Minterm 3 plus Minterm 4 plus Minterm 6. Okay, what is number 2 in binary? It's 0, 1, 0. What is number 3? It's 0, 1, 1. What is number 4? It's 1, 0, 0. What is number 6? It's 1, 1, 0. What are the variables? Variables are A, B, C. So here, because we have 0 for A, we say A bar. B, C bar. For next one, A bar, B, C. For the next one, A, B bar, C bar. The last one, A, B, C bar. We need just add these minterms. And this one is the function. Okay, so we got the function directly from the minterms, so we don't have to do the truth table. So let's see what we can do here. I want to simplify this function. So from the first one and second one, I factor out a bar b, and from third one and fourth term, I factor out a c bar. So let's see what we will have. From the first one and second one, I said we factor out a bar b, and we will have c bar plus c in the parentheses. From the third and fourth term, we factor out a c bar, and we have b bar plus b. Okay, we know that c plus c bar is 1, b plus b bar is 1. So function will be equal to a bar b plus a c bar. Okay, this one is the simplest sum of product form. And now we just need to find draw the circuit. So we have A, B, C. Here is A, here is B, here is C. We need the complement of A in our design, so we make it. We don't need a complement of B here, so we don't need to draw it. And we need a complement of C. We have it. And the first one is AB, A bar B. So A bar B. The second product is A C bar. Okay. So this one is A bar B, and this one is A C bar. We bring an OR gate and all these two functions, and here is the circuit. Okay, so we designed the circuit. The next thing we should learn, what if we have this form of the function and we are supposed to convert it. This one is of course non-canonical, so and we are supposed to convert it to the canonical form. So we know how to simplify from canonical form to non-canonical form as we did now. But what in the like a reverse way? So how we can convert a non-canonical form to a canonical form? Okay, let's see how we can do that. So converting non-canonical to canonical form. Okay, just I show it with examples. Let's say we have this circuit. F of A, B, C is equal to A bar, not A bar, A C bar plus B C bar plus A B C. Okay, by looking to this function, we know that we immediately recognize that the last term is a Minterm, but the first two terms are not a Minterm because they not included like all variables A, B, and C. So how we can convert it to the canonical form? It's easy. First, we write the first term, which is missing variable, and multiply it by the missing variable, uh, like in this form: A C bar, B plus B bar. Why? Because we know that B plus B bar is 1, and it doesn't change any functionality of the function. B plus B bar is 1, so we can simply add it to any term we want. So we can multiply B plus B bar with the first term in order to make it in the form of canonical. The second product is BC bar. Which variable is missing? Variable A. So we multiply it by A plus A bar. The third one is ABC, which is already a Minterm. So we multiply, expand these like terms, and we will have A B C bar plus A B bar C bar plus A B C bar plus A bar B C bar plus A B C. Now if you look to this function, you see that all the products are Minterm. We should look for any duplicated terms, so because we multiply them, we may find some terms that are repeated. So let's see, do we have A B C bar anywhere else? Yes, of course we have here. You see A, B bar, C. What about A, B bar, C bar? We don't have A, B bar, C bar. What about A bar, B, C? We don't. What about A, B, C? We don't. So this term is repeated. So we remove one of them and we say it's equal to A, B, C bar plus A, B bar, C plus A bar, B, C bar plus A, B, C. Okay, that's it. Before moving to the next example, which is converting non-canonical to canonical in the form of product of sum, I want to show you one other simple example. So f of a, b, c, which is equal to a plus a, b bar, c. If we look to this function, we want to write it in the form of sum of product. So if we look to this function, we see that the second term is a minterm, the first term is not a minterm. It's missing two variables. So we say it is equal to A. What are the missing variables? B plus B bar and C plus C bar. Okay? And now plus A, B bar, C. So we need to multiply this a with this parenthesis to convert this function to canonical. You can do it at home as a practice. The next example is converting non-canonical to canonical in the form of product of sum. So here is the function f of a, b, c is equal to a plus b bar, b bar plus c, a plus b plus c bar. Okay, now we want to convert it to canonical. The third term is of course a minterm, so we don't need to worry about the last term. The first two terms we need to modify them in order to convert it to canonical form. So we say f is equal to the first parenthesis, the first term is missing c. So we say a plus b bar plus c times a plus b bar plus c bar. You see how we added c, so we wrote this term twice here and here and added c and c plus in order to convert it to the canonical form. The same thing for the next parenthesis, b bar plus c plus a, b bar plus c plus a bar. So here we wrote this function twice and added a and a bar. The last term is already a minterm, and that's it. So we have the function. Okay, so we can say function. First, let's look for any duplication. A b bar, a plus b bar plus c. We have it here as well. So we keep only one of them. Okay, so we say a plus b bar plus c, a plus b bar plus c bar, a bar plus b bar plus c, a plus b plus c bar. Which minterms are, which max terms are here? So a is of course 0, b is, I'm using max term codes, b bar is 1, c is 0, a is 0, b bar is 1, c bar is 1, a is 0, no, sorry, a bar is 1, b bar is 1, c is 0, a is 0, b is 0, and c bar is 1. So this one is max term number 2, m2. This one is Maxterm number 3. This one is Maxterm number 6. And this one is Maxterm number 1. So we can say this function is the product of these Maxterms. Maxterm 1, 2, 3, and 6. So we had a non-canonical form of the function, but we converted to canonical, and then we wrote it in the form of maxterms. Okay, in the next lecture we will talk about some other gates and methods.